Hello students, today we shall discuss new chapter, that is electromagnetic waves. So basically electromagnetic waves are nothing but both electric fields and magnetic field coupled together. How this is possible? We already know that changing magnetic field can produce electric field. Changing magnetic field produces what? Electric field. What electric field? That is electromotive force or potential difference, and from potential difference we get electric field. So this is according to Faraday law. Changing magnetic field produces electric field. Similarly, changing electric field also produces magnetic field. Okay, one example is our Ampere's law. Okay, but Ampere's law does not say that changing electric field produces magnetic field. It does not actually you cannot say this is Ampere's law, okay, but you can relate it with Ampere's law. What Ampere's law says? Ampere's law says if there is a current, there will be magnetic field around it. Okay, this is the Ampere's law. Or from that law we can find this magnetic field value. This statement says changing electric field produces magnetic field. Actually this was proposed by Maxwell. It was proposed by Maxwell. Okay, so accordingly there are 4 equations on the basis of the discovery of Maxwell. I will not go in detail for those equations. We shall discuss how Maxwell decided that changing electric field also produces magnetic field, and from that we get a concept of displacement current. So next topic is displacement current. We shall now understand how changing electric field produces magnetic field. Suppose a capacitor is there, parallel plate capacitor. Okay, now let us, each plate contains a charge of plus q minus q, right, respectively, and area of each plate is A. Okay, now suppose capacitor is being charged. If it is being charged, that means some current is flowing through it. Let this current is I. Then if I draw a hypothetical Amperian path here, from the Ampere's law you recall that we can draw here the Amperian path, and at each point of Amperian path there will be one definite magnetic field. For this current there will be definitely one magnetic field, no doubt about that. And what will be the value of that magnetic field? We can determine it by Ampere's law, that is B dot dl is equal to mu naught I enclosed. Here this is the point P where we want the magnetic field, that is B. Mu naught I enclosed, here I enclosed is I itself. and this is okay for this. Now current is also flowing on this side also. We can also apply here these things, but we cannot apply here because there is no connection. They are separated. But still current is going. Here current is entering, here current is coming out. But we can easily see that there is no current inside. Then how is it possible? How is it possible? So and moreover, if you measure the magnetic field here, you will get the same value here. Okay. At this point, you will get the same magnetic field B here. Okay. Then how come this is possible? If there is no current but still magnetic field is appearing, that means some current is flowing here, but we cannot say that this current is equal to this current because this is already physically flowing through a material, but there is no material inside. That means you cannot say this is physical current. That means something else, but current is there. What type of current is that? That is called displacement current. Displacement current. So this is the current that produces magnetic field inside the plates. Okay. Now we shall find out the expression for this displacement current. How this displacement current is coming. Okay. Suppose. Okay. Now first I will start from electric field inside the. What are there inside this, in between these plates? First of all, there is one electric field. Recall from parallel plate capacitor topic that electric field inside the capacitors is sigma by epsilon naught. This is equation 1. Another thing, if electric field is there, this is plus, this is minus, means electric field will be like this. If electric field is like this, that means there is flux inside the plates. So what is the flux formula? Flux is nothing but E into A. Electric field into area, and area of the plates is A, already given. This implies phi is equal to, in place of E I can place sigma by epsilon naught. Sigma by epsilon naught A. Okay. Now see what is sigma here? Sigma is nothing but charge density of plates. We already know it. If sigma is the charge density of plates, area A is the area of the plates, then what will be the charge Q? Nothing but sigma into A. This implies I can simply write phi is equal to charge by epsilon naught. Now if I differentiate on both sides, left term will be d phi by dt. This is equal to 1 by epsilon naught dq by dt. So dq by dt will be, this is written on the left side, so this will be equal to epsilon naught d phi by dt. Now you see, on the left side there is a term which is dq by dt. What is dq by dt? It's nothing but a current. So what type of current? We are finding it inside the plates, dq by dt, but how come this is possible? That means it is a current and there is no physical current here. So we shall name it something different. That is called displacement current, IDIS, or simply you can write ID also. Displacement current. This is equal to d phi by dt. Okay. Now the question is how this ID is produced. Inside the plates electric field is there. Rate of change of charge is ID. If charge is changing here, that means this electric field is also changing with respect to time. If electric field is changing and we are getting a current, that means we can say this current is because of this changing electric field. Okay. Now we are getting here magnetic field, means this magnetic field will be because of this current. That means we can say this magnetic field is produced by the changing electric field inside the capacitor. That's all. Okay. So this is displacement current expression. Now come to the Ampere's law. What Ampere's law was saying? Circulation of magnetic field is equal to mu naught I. But what about I here? We can apply I outside, but we can't apply I inside, because this I is not valid inside. Inside the capacitor, this I is valid. So we shall total write outside current is I, inside current is ID. Okay. Now you must be thinking, how come this is possible? It is very simple. If you are outside the capacitor, ID is 0. That means formula will become simply mu naught I. If you are inside the capacitor, I will be 0. ID will be having some value. Then I will be 0, ID will be present there. Okay. So this is the way this formula is being used or incorporated. Now this is the final formula or modified Ampere's law. This is also called Ampere Maxwell law, because Maxwell modified it and Ampere proposed that law. That's why. So this is our displacement current. Then what is the expression of displacement current? That is epsilon naught d phi by dt. That's all. Thank you.